Hey you guys! Today's theme song is Can't Feel My Face because I just got back from the dentist and can't feel half my face. So if you hear me like slurring, please excuse that, and let's just get down to graphing. Now, I want to do 3 different problems. I kind of just came up with them myself, so I think they'll work out pretty nice. But there's a few things that I want to make sure that we cover. First and foremost, I want to make sure to show you, particularly side by side, 2 problems to compare, and then we'll do the third one, which is going to add the concepts of holes. So, first, I want you to see a problem that looks like that versus a problem that looks like this. Now, I know, 45, okay, I know that you guys can see the difference. But I don't want you to forget about this guy, because we get so caught up in knowing all of the different, like, tiny things that we have to do for this, that we forget about that guy. So, for this guy, remember, whenever you see something that has only one x in the denominator, there's, like, just a number, no variable on the top. And there could or could not be some extra number here at the end. That doesn't really matter. The big difference is that there's only one x on the bottom and just a number. Now, this may have a polynomial on top and a bottom. It may have a polynomial just on the bottom, and just a number on top. But the point is, this one has only one x. There can be only one. So, remembering how to do this guy, this, whatever is with the x tells you how to move, and remember if it's with the axis backwards, so I'm going to change the sign, so since that's negative, I'm actually going to go to the right 3, and this means that I'm going to go up 5. So, when you go ahead and you do your graph, remember, this is a graph that usually starts at 0, 0, it looks like crosshairs, and all you're going to do is you're going to move your crosshairs to the right 3, 1, 2, 3, and up 5, 1, 2, 3, 4, 5. So I'm going to move my crosshairs. They're now going to be there, and I'm going to go ahead and tell myself that I have a v-tote at x is equal to 1, 2, 3, and a y-tote, an h-tote at 1, 2, 3, 4, 5, right? Notice how the numbers do match up, but I really do recommend that you graph first, because a lot of y'all switched this order on your quizzes, or if you for some weird reason saw these numbers and just did something else, and did those h-totes before graphing, then your graph was off. So just do it in that order, save yourself some trouble. Now, I'm going to ask you for shift on the test, and this is what I mean. How did it move? And the only other thing that I really ask for, and y'all know, is the domain, and that always matches the v-tote, and I'm just gonna say that it is everything except for that v-tote. Now, it would be nice if I actually drew the graph on here, right? So what I'm gonna do is I'm always gonna go to the top right corner, give myself a curve, and then to the bottom left corner and give myself a curve. Remember, for these, I just care that you ballpark. Like, I don't need any other information. These guys, on the other hand, are a little bit, they're a piece of work, right? First and foremost, I need to factor this guy. So I noticed that I have 5 there, so I'm going to go ahead and take that out. So I have an x squared minus 9 left, if I hopefully did that correctly in my head when I came up with the problem. And then, you know that I came up with this problem because there's a lot of differences of squares here, right? And I really like those. So, I have this, and now I can start my procedure. So, I'm going to always ask you for a long laundry list of crud for stuff like this. And it's going to be the zeros. Oh, I'm going to ask you if there's any holes. The zeros, the v-totes, the h-totes, and then the y-intercept. And then y'all know that I'm probably going to ask you for a little wave graph that's going to tell you how to shade, and then finally for a whole nice big graph. So, first and foremost, are there any holes? Well, I'm going to try to give you another problem with an actual hole, but here, does anything cancel out? No, and that's usually where I'm going to have a knowledge hole, in other words, something that canceled out. Something I don't really know about. Well, it doesn't happen here, so I'm going to put none. So that means that I'm stuck setting each of these factors equal to 0. Do I have to set that 5 equal to 0? No, because I don't have a variable there. So I'm going to take that x plus 3, I'm going to set it equal to 0, so when I move that 3 over, I get x equals negative 3. So I have a 0 at negative 3, 0. I do want zeros, which are points, as coordinates. But notice I also have a 3, 0. Now, my v-totes come from the bottom, which means I'm going to have a v-tote at x equals negative 4 and at 4. Notice how these are actually equations of lines, so I don't want them as coordinates. H-totes is, I really liked this last year. They came up with the whole Bobo bottom, which is if it's bigger on bottom, then y is equal to 0. So what do I mean by bigger? Well, I'm going to look at the original, I'm going to look at the degree, the power, right, the exponent. So which one would be bigger? If it's bigger on the bottom, then it's going to be an automatic line at y equals 0. If it is bigger on the top, then there actually is no horizontal line, and those graphs look weird. Now, if it's a tie, like in this case, if these are equally powerful, I'm going to take the leading coefficients and I'm going to divide them. So I know I have an h-tote at y is equal to 5 divided by 1. In other words, y is equal to 5. Okay, so I'm going to go ahead and find my y-intercept, where I always do that by finding where x is equal to 0. So I'm going to plug in, and I get 0 minus 45 over 0 minus 16. Now, I obviously didn't plan this because it didn't come out nice, but in my test anyway, I want a fraction. Now, if you actually find that number, it is 2.81. Now, I'm only telling you the decimal because even though I want the fraction for the test, this is going to help me kind of ballpark where my graph is going to go. Okay, so let's go ahead and do the wave. That guy is going to come from the zeros, and I purposefully chose a lot of crud for you to graph, and from the v-totes. So these two things together. So notice how there's a lot of stuff on the wave here for me. Now, I'm going to look at my leading coefficients. Both of them are positive. There's no negative there. And I know that I always start on the right, and the fact that these are positive tells me to start on top. None of these bounce, and so I get a weird graph that's going to be above the x-axis, then below, then above, then below, then above. So if you follow my advice to go ahead and shade first before you put in your structures, then you're going to go to -4, and above -4 you're going to shade. Between -4 and -3 it's going to be below. Between -3 and 3, be careful, it goes all the way to 3. Across that 0 it's going to be above, then below, and then above again. Okay, so let's actually put in all our structures. At -3 and 3, I have dots. At -4 and 4, I have lines. Oh, over here. At 5, pretend that this is 5, I have a horizontal asymptote. I have a h-tote. And at y is equal to 2.8-ish, I have another dot there. Okay, so this is really good for you guys to see because I actually just came up with this problem, which means that I had no idea how this graph was going to look. So I know that if I have dots, I'm going to try to connect them, right? If I have these shaded sectors, I know that every sector is going to have a line on it, and I'm only allowed to touch there. So 1, 2, 3, 4, 5 sectors. Well, I'm going to connect 3 of them with these dots because I'm just itching to draw myself a parabola. That means I took care of these 3 sectors. Well, this one needs a curve, and I'm going to go ahead and do one on top here, and I can just ballpark. I can't be down here because I'd go outside of the sector, and I can't do that. And then I'm going to give myself another one there. So pretty, complicated looking graph, but this was pretty good. All right. Okay, I gotta hurry because I'm coming up on my 10-minute mark. I'm going to do one more with a hole. So we'll do something that looks like this, and we'll do it really quick. Alright, so I'm going to factor this guy. I hope I'm factoring this correctly. And I'm going to give you my laundry list again. So whole, 0, v-tote, h-tote, and y-intercept. I know I'm going to have a wave, and I know I'm going to have a graph. Okay, so first and foremost, I know you are itching to, just like me, cross these out, right? That's where my hole is. Now, the hole is actually, so x plus 2 is equal to 0 when I move that over at negative 2. This is actually the exception. Usually, whenever I have a dot on a graph, I want you to actually give me the coordinate. That would be too much work, in my opinion, because then you'd have to take this and plug it back in there, and then tell me where the actual coordinate is. Don't worry about it. With the holes, just tell me x equals blah. Then I'm going to keep going. The 0 is going to be from the left over top. So I'm going to go ahead and say that I have a 0 here at negative 2, 0. I have a v-tote at x is equal to 2. I have an h-tote, well, they're equally powerful, so I'm going to take the leading coefficients and divide them. So y is equal to 1. And then I have a y-intercept at x is equal to 0, right? So y is equal to 0 plus 4 over 0 minus 4, which means negative 1. So I have a y-intercept at 0, negative 1. Okay, so remember, these two things are what's responsible for the plus-minus chart, the wave, right? So I'm going to go to negative 2 and 2. This is not horrible because both of these are positive. I'm going to start at the top, nothing bounces, no double roots, nothing squared. We just have plus, minus, and then plus. So again, if you're following my advice to shade first, you're going to go and above the x-axis to the left of negative 2, between negative 2 and 2 below. You guys are getting pretty good at the shading. And then to the right of 2, shade above. Okay, let's put our structures in place. I know I have a dot at negative 2. I know I have a line at 2. And then I know that I have another line at 1. Pretend that's 1. And I have a y-intercept at negative 1. Well, this just looks like it's going to be something where if I connect the dots, I have 1, 2, 3 shaded sectors. I can get rid of 2 of those shaded sectors by connecting those dots. And then I can ballpark the other curve to get rid of the third shaded region without having to, like, really draw another curve. That's crazy up there. But I'm missing the whole point. Why is there a hole even in my laundry list if I'm not going to take care of it? Well, I am at negative 2, so wherever I see negative 2, I'm going to go try to find wherever I had a curve, and it was right here. And I literally just want you to draw a hole on the graph, and since I'm a little bit OCD, I'm actually going to blot out that hole and say I skip that dot, and that's my final graph. Alright, so those were 3 interesting problems. I really wish you guys luck. I'm regaining feeling on my face, which is good. So, good luck. See you tomorrow.